Jay, take us live.
Yep, alive. Should be popping.
Hi, and welcome to the second part of the impromptu live stream of Total Space, special episode with guests from Nexus Aurora. In the second half here, what we're going to be doing is we're going to be looking to break out into questions from various people, either in our listener audience or some questions we have lined up here as well for the various people here. So, first of all, I'd like to pass to Elo to answer a question that one of our listeners, Warhawk, asked earlier.
All right, so he asked whether or not we're going to have those suit locks that attach to, the side of a vehicle or something. And those are actually very good for smaller scale deployments, but for a giant city, the main issue of contaminants and dust actually comes from very large vehicles and cargo containers that have to be moved from the outside into the city and back and forth and back and forth and back and forth, compared to the relatively minimal number of EVAs that would be going on any given day. So, if we're going to have to deal with the dust anyway, we might as well just standardize the sizes of the airlocks, standardize the design, and generally make less holes in the city rather than more. It's one of those things that the dust gets everywhere. You have to deal with it anyways, and it's better off learning how to deal with it than to actually, make a very specific system for a very specific scenario that really won't affect anything much. Or talking a difference of maybe 0.5%. And at that point, really, economies of scale and production volumes come into play more than any sort of research or technical aspects do. It outweighs the benefits of the simplification of research and technology, simply because the fact that by the time you have so many airlocks, I think, I think one of the 570 has something like 10 different airlocks. And it's one of those things where you have something that needs to be taken care of, so you generally want to design things to handle the dust, to remove the dust before it gets in, because the spacesuit isn't going to be the hard part of it. It's going to be the cargo container. It's going to be the space tractor or the train that's coming in. Sam and I did a lot of work on this as well.
Yeah, I can talk briefly about how our proposed idea, just to give an idea of how this works, as one proposal for this, as for how you would get stuff out of a cargo container. So you've got something, imagine a sort of 20-foot or 40-foot TEU like you'd have on the back of a truck, has been sitting in a cargo yard on the surface of the planet full of rolls of steel the past 6 months, and you want to get the steel out. There are a number of ways you could do that. You could have someone go out on the surface and with a trolley and start trying to load steel out, which is slow and exposes them to radiation. You can have big vehicles lifted up and move it through airlocks. That then brings dust in on the outside. What we propose, the sort of full multi-stage thing, you take your container, you bump it up against the side of an airlock, open the doors, pull in some sliders, similar to those pallet slider things, pull them all out into your airlock, into a low pressure zone. That's then you do all your processing in there. The airlock that you go through from the outside to low pressure has all the normal sort of airlock stuff, blast down stuff, electrostatic precipitators to get the dust off into a low pressure, and then again for the high pressure zone. So it's this big multi-stage process, and it seems more complicated to do that, but this system can work for any size of vehicle. You can get a whole train into one of these things. Whereas if you go with a suit lock or something of that scale, where it's this very specialized, very well optimized system, it works for one thing only. And then if the gravity means everyone gets like 5% taller on Mars, good luck, you have to make new suit locks. So that's the kind of philosophical approach we're going with how do we generalize this and find the best solution to the general problem, not this super specialized focus problem.
Yeah. As for the suits themselves, they're actually going to be we are actually working on in ESS a mechanical counter pressure suit that is designed to be more flexible, much lighter, and by much lighter, we mean we're trying to get the weight less than 200 kilograms, which is, quite frankly, would be amazing. Because NASA suits weigh, just the suit, not the life support, weigh something like 300 alone. So we're trying to get it under there. We're trying to get it to a level where we can actually pressurize it. We're trying to make it lighter, more comfortable, fit better, and generally actually faster than the current generation of spacesuits. A lot of our innovations come from the fact that, well, and I think this speaks well for the entire project, we're taking the very fundamental concept of, okay, so this is what we need. Here are the ways to get it. Let's try it out and see what works. The project works because everything is being built from scratch. Everything it has to be reevaluated, be reevaluated, and is being reevaluated. That's how you get revolutionary thinking. You start from first principles.
So I have a question. It's mainly directed towards Adrian and Cohen, but it can be open to the entire floor as well. When you were doing the Mars colony design contest as Nexus Aurora, from inception to completion and submission, roughly how long did it take?
Yeah, that was quite a short time frame or window. We had 2 months and 2 weeks, if I remember right, or even less. So we started with like a bunch of people, 12 or so, and there was like a lot of chatting ongoing, and continuously we started adding more and more people to the team. So some of us are here from week 1, and some have joined like even in the last 3 weeks of the process of getting this document ready. It was like 3 quarters a period of like brainstorming, intense brainstorming, a lot of questioning and so on. And in the last 2-3 weeks, we created a team of top contributors that put together all these documents in a summarized form, and from here on we assembled all together in a, let's say, prettified version of it. So 2 months and 2 weeks rather. That's a guesstimation.
Yeah, and I could add to that was actually not the end of the whole Nexus Aurora project, because we were really wondering how we would fare against competition in this case, because when we read that there were 175 competitors, something like that, from all over the world, universities, all of that. So we're like, okay, if we are in the top 20, it would be really, really great. And let's just hope for that. And that's what we did. And we waited a bit, and some people kept working on some smaller projects, but we were actually just really wondering, like, are we actually going to make it to the final 10 even? Because that was another press moment. And then when we read that in the press release that we're in the final 10, we were really, really ecstatic, because then we were like, oh shit, now we have to present. Now we have to really make a nice presentation. And that was, I think, like 3 weeks before the actual presentation or something like that. So then we had to scramble, and we worked all very hard on a Google Slides presentation, just so we could all work on it at the same time, and try to use the imagery, but also try to find out who will present, which parts will be presented, what will we present, because if you can do a recap of the whole 20-page report, but is that very interesting? We thought not. So we took a different approach and actually talked about stuff that we wanted to talk about, but 20 pages was not enough for it. So then we did that approach, and I think we answered during this live presentation, we answered the questions correctly, according to the judges at least. So that was great, and we were the last to present. And the cool thing was, for me at least, is that the nice thing about this community of Nexus Aurora itself is that some people were in completely different time zones, of course. People from the US, people from South Korea, South Africa, Europe, all of those places. And we stayed up for hours to watch when the final announcements were made. And that was really great moment I really liked that moment because it was like 3:30 a.m. for me, something like that. And I was wide awake because we were just having fun with all of these guys, and we were having virtual and real beers, drinking to what we hoped would be a first prize. And when we won it after a sort of a pretty messy announcement, there were like 5 PowerPoints open in the background, and we were like, "Oh shit, what's going to happen now?" And then when we won, it was really, really, really. A crown to the hard work that we did in the past months, and was really a good moment, and really fitting to be with 10 people in the middle of the night talking with them, and was a great moment.
And
So-
for anyone watching, you can say if anyone hasn't seen our presentation, I believe it's linked somewhere. If it's not linked yet, it will be linked soon. Our half-hour presentation to the Mars Society, because it's a very, very polished presentation. This is a bit of a because we're just chatting at this point. But if you want to have a look at this very polished thing that tells both the story of how we built the idea and also the narrative behind the design, it's a very good place to look at it.
So just quickly, guys, for anybody that might be watching this video that's interested in coming to find out what Nexus Aurora is about, contributing, where can they find you?
So you can find us at nexusaurora.com. We have a presentation that summarizes what's happening there. We also have like a welcome brochure. That's a welcome.pdf at /nexusaurora.com. So there's a lot of information that we have ready on hand, but we like to actually answer them in person when people arrive. So that's the magic of this community. We've been here like almost 9 months since we started this entire thing, and many of us have deep connections with each other. So it's like building a friendship more than just a team. So
And just to be clear, people can join our Discord server as well. That will likely be linked at least in chat or otherwise below the video. And the interesting thing to know about Nexus Aurora is that we have grown into a community with many Discord servers. So when you enter the Nexus Aurora Discord server, our main server, where many people come to chat and talk about different projects as well, you can actually find links to other Discord servers as well with very specialized topics, from moon rovers and specific research projects that we have talked about during this conversation. But also extraterrestrial architecture and spacesuits, whatever you like in the space domain. There's a project working on it, and if there's not, you can start your own, and we can help you with that. So feel free to come to Nexus Aurora, to our Discord server, and feel free to ask us, tag us, and we'll help you along and work together to make humans a multiplanetary species, of course.
I like it. Hosting a show called Becoming Multiplanetary, I definitely like that. So, do we have any more questions from our own community, or...?
I think Mike had questions, but I think he's quite happy to sit and discuss those later. He likes picking things apart.
If you have questions, we'll do our best to answer.
No problem. No problem. Right. Sam, would you be willing to elaborate a little bit more about your autonomous agricultural drones that you were talking about?
So, I'll zoom out a bit before I talk about the robotics and talk about sort of the mission directive of M5D, our server. M5D, by the way, it's a very bad acronym. It's Mars Mission Mining Materials and Manufacture Division, because we wanted to have something that was as snappy as an acronym, but not as a title. Is our project at Nexus Aurora looking at industry in the broadest sense of the word. So that's everything from air mining to mining to water mining to farming, and then everything that takes that and turns it into stuff you actually want, rather than a load of crushed rock. So the scope of the project is vast. It goes from first landing propellant production, Sabatier, how you actually build the Sabatier plants for your very first landing, all the way up to working with the amazing chemical engineering team to how you make toothpaste, which is a whole lot of stuff to cover. We don't really have the manpower to cover all of it, but we're looking at the stuff that we can do in the very short term and put real engineering into, rather than and take the science that's coming out of the EHRI, the science that's coming out of sort of the cutting edge research, and look at how that can be implemented. And one of the ways that we're working on that, one of the sort of media that we're using to develop this, is a project that the Mars Society runs, the Desert Research Station in Utah. I suspect many people here will have heard of it. It's an analog station. It looks like a Mars station in the Utah desert, so it looks a lot like Mars. And for about 6 months of the year, they run analog missions for 2 weeks where 6 people pretend to be astronauts and go around in fake spacesuits and do things that will work out how you will run a Mars mission. The operational principles, the technology, how the crew can work together, the psychology of it. It's a really great thing they've been doing for years now. And they've been very welcoming. They've invited us to bid for some projects for that. And in M5D, we said, okay, let's try and take a step closer to utilizing resources on the ground. We know that Mars is there. We know roughly what it has on it. How can we turn that into useful products? Or how can we get a step closer to usable materials and usable stuff for human civilization? So we're looking at sort of the whole spectrum there. We've got one project that we're proposing is we want to land a crate with 5 tons worth of robots and get as much information about Mars as we can. So we want to make hundreds of robots that fit in this crate and can spread out across the surface. How can we actually build those? Can we build 5 of them for like under $1,000 and then ship them to Utah and let them play around in the sand and see what they come up with? We want to get the dust off suits and try and collect that and say there will be perchlorates here. How can we get those out and store it? Or in my case, I say we want to do farming that'll allow people, sort of farming on a scale large enough to actually feed people their entire diet. We can't have someone with a trowel doing that. That's ridiculous. You need to have that automated or mechanized. Eventually, that'll mean tractors, space tractors or regular tractors. But in the intermediate term, you need a robot. So my project that I've been leading for a couple of months now, and will be hopefully putting into hardware in the next year, is doing a design and build with some open source hardware to try and get a robot that could, in theory, farm like 100 square meters of land completely autonomously. You plug it into water and power, and then it emails you a month later saying your carrots are ready. That's the sort of aspirational goal here, which I think a lot of us would love on Earth. I'll be honest. I'd love to have automated carrots. Obviously, it's going to be an engineering process to get there. It's not going to work perfectly the whole way through. We'll probably run into some obstacles, and you'll have to go out and kick it every now and again. But if you're interested in this kind of thing, do join us. Like, it's an open project. We're very much looking for people. We've got this core proposal, which will be going in. We're very much hoping to get selected in some regard for it, and then we have hardware to build, which is tremendous fun because it's how many students can say, "Oh, over my summer I did this stuff and this stuff, and I built some farming robots for Mars." It's an absolute kick to be with a community that is such a sort of diverse backgrounds and global community, and then do something really, really practical.
That's actually pretty interesting stuff. But, I was just thinking to myself when you were saying about having a robot just farm at 100 square meters, I was thinking, I've seen people attempt very similar things on like Minecraft with mods and stuff like that, having this completely automated farm. I'm just like, yeah, I can see the appeal.
We've called M5D Factorio for Mars, and I think that's a fairly clear, like, we don't want to just I'm guessing you played Factorio or something like it. Where you have the research lab that generates technology. We're in the research lab making the technology to build everything automated. I assume some people will get that joke, some people won't. But yeah, that's sort of the goal we're going for here.
Awesome. And Elo, would you want to take Framric's question from the live chat concerning power?
Yeah, sure. So originally there was an issue of power. The city needed Cohen, how many gigawatts of power was it?
I think 40 gigawatts was our
Yeah,
estimate.
something like that. It was quite a bit because we had to process all our oxygen. We had to process a whole bunch of other stuff. It was a lot of energy, and the only really viable way to do it was nuclear power. So, but of course, there are various treaties in place around the world regarding the shipment of weapons grade nuclear material into space for very obvious reasons. And it's one of those things that's very, very tricky because the efficiency of a fissile material goes up the more you enrich it, the mass efficiency. So if you have weapons grade uranium, that's going to be almost like 3-4 times more efficient than your average reactor grade uranium, and your average reactor grade uranium is much more efficient than natural uranium, which barely undergoes any fission at all. So we had the problem. Do we ship the uranium from Earth, or can we mine it on Mars? If we can mine it on Mars, how much do we have to enrich it for it to be useful? And so there was a fairly large debate that happened, and eventually what happened was we decided on the CANDU reactor design, or something based on the CANDU reactor. Me and Sam don't know the specifics of it because it was someone else who actually went in and did all the math for it. But we decided on this because, one, our reactors really can't fail. There's a saying that the difference between something that can fail and can't fail is that when it does fail, the one where it can't fail is a million times harder to reach. So our reactors had to be fail-safe. And the CANDU reactor design has an inherent advantage in the fact that it places the cooling medium above the reactor. So in the event of power failure, an electromechanical safety engages, or I should say disengages, and dumps all the water and cooling medium, cooling rods, neutron moderators into the reactor to prevent a meltdown. The reason why we were going for larger reactors rather than small modular reactors is the fact that they tend to be more efficient per volume than small modular reactors. And the other argument for CANDU is the fact that it can actually run on lower grade enrichment grades, so we don't have to do as much processing for our uranium that we mine on Mars, meaning we don't have to bring in more hardware from Earth. And eventually we can probably go to different sizes of reactors, different types of reactors, but overall, the less processing we can do, the better. And from that, if we can gain a significant amount of power while still being safe, it is very attractive to us.
Maybe it's also interesting to explain, and then I'll give the word to you, Sam, that there's like a phased approach also in the energy production for our Nexus Aurora colony. So we wouldn't start out with bringing over a huge nuclear reactor with the first outposts. So let's say phase 1 was, I think, up to 500 people that we determined ourselves at least. And then mostly that would be energy generated by solar power, because that's a skill that you can still handle. But once you go bigger, and once you see that, for example, you want to melt entire glaciers to get a lot of water to create as radiation protection above the city, which was our design, then you're really going to need a lot more energy. And that's why we decided on this phased approach and to have a bit more time to get to this phase with nuclear reactors when we have more people on Mars as well.
Chip in as well about the all these sort of SMRs and submarine style reactors. There's a very real political reason not to have enrichment on Mars, because you don't. If Earth controls your shipping that gives you all your electronics, you really don't want someone on Earth saying, well, those guys have uranium enrichment, let's do an Iran nuclear deal on them. Because if we can get away with CANDU, the really great thing about it is it's entirely unenriched. There's no way to turn CANDU into a bomb. It's completely impossible. Whereas if you have any centrifuges, we've seen what happened with Iran politically, where they said, oh, they're totally for civilian use, right? Aren't they, guys? you don't want that happening with Mars when Earth controls your entire like resource economy. That's really not a great outcome. So even though, yeah, like stuff like small modular reactors or even like molten salt, molten fluorine reactors may win out technically in some regards, and they might be better for certain applications. Politically, if you want to build more power in situ, stuff like CANDU is actually a lot better, in our view at least.
So to expand on another question in the chat that's been asked about thorium, yes, thorium would be great, but, and this is a big but, it does need a uranium starter charge and accelerator to actually start the reaction because it's not fissile itself; it's fertile. So again, that's the main reason we haven't decided on using thorium, because it does need this accelerator, and shipping that uranium from Earth tends to have bad effects. I know Henry and I wanted to use nuclear bombs for mining.
No, let's not get into the nuking Mars now, please. We have had a very long and running meme.
I know, and we've had a long discussion on why it's not viable, but we did calculate that 3 SAR bombs would be enough to supply Martian industry for something like a century or two.
You've heard already about apochlorite mining, about how you want unique explosives to fracture rock, same as on Earth. On Mars, if the surface is radioactive anyway, why not just use a nuclear bomb for that? The answer is many reasons not to do that, but that hasn't stopped us asking it. And that's the kind of thing with no one sane in the aerospace industry would come at the problem and say, do you know what? Could we just nuke like near the colony, but not actually on the colony? Would that help? Most people wouldn't even ask the question. And what we did is we asked the question, and the answer is no, it's a bad idea. But that's what Nexus Aurora brings to the table, is the people who are crazy enough to ask those questions.
All right. Would you like to present a bit the experiments that you run in your backyard and all this interesting research that has been happening meanwhile?
Sure. I can't do nuclear stuff, but I can definitely do blasting. Actually, I did a lot of fun little experiments. Honestly, we've been talking about how to build pressure vessels. So I basically took my heat laminator and some basalt fiber that I had previously ordered some basalt fiber for composites, and you can heat laminate basalt fiber in just like a document laminator, and you can make a little pressure vessel, and it totally holds 1 bar. So that was kind of fun, interesting. A pure plastic pressure vessel has problems with creep, especially at elevated temperatures. But basalt fiber is pretty dang easy to make. Actually, that's so with Ilho, we looked at every possible way to melt basalt. And there's a lot of different ways to melt basalt. You can melt it in a microwave oven. That's something that we did. You can melt it in a induction furnace. That's something he tried. I've done solar concentrator basalt melting. And if you have a blob of molten basalt, you can pull out strings of basalt fiber. So yeah, I've been trying lots of little, sort of goofy, off the wall, sort of home backyard style experiments for these things, and yeah, cool. So that that's a chunk of you made some basalt fibers then.
Yeah, this is a chunk. So I asked. This is an entirely accident. I was trying to pull out the molten chunk of basalt, and yeah, this is what came out of the induction furnace. It actually came out as a fiber. The very tip broke off, but it was about yay long before I dropped it on the ground, and it sort of splattered everywhere and burnt the floor.
You can accidentally make basalt fiber. That's how easy it is. And honestly, like the very first few things that you build, I mean, the land a rocket and start making X, that has to be backyard caliber stuff, right? It can't be some extremely sophisticated, complex industrial process. It's got to just be some bare, simple thing like shovel rocks into a hot thing and they melt. And basalt absolutely melt. It has to be hot. But honestly, in space, keeping things hot is often, in some ways, a lot of these things I think will be easier, right? Lower gravity on Mars, much lower gravity on the moon, lower atmospheric pressure means that you have less, conduction heat losses, convection heat losses. So I don't know. There's a lot of interesting industrial processes that seem really feasible. So we had this idea like perchlorate-based blasting. Can you do this? Is this buildable? So yeah, it turns out it is totally buildable, and it was really fun to to blow up a rock is something I'd never done, and it's totally feasible. Yeah. So good question from the chat. Like vitrify Martian material, if you heat up basalt, and that's like the most common kind of rock in the entire solar system, honestly. It melts. It melts at a fairly reasonable temperature, like lower than molten steel. It's slightly above. It's on the order of 1,000 centigrade. It depends on the exact chemical composition, which does vary a little bit in different places. But it gives you a beautiful black glassy obsidian, and it's if you heat it for a really long time, it tends to devitrify. It crystallizes back into more of a granite type substance. But if you heat it fast and cool it fast, you get a very nice glass. And yeah, totally feasible. I don't know if so it has a really big thermal expansion coefficient, so it tends to break if you try and make really big stuff. So I don't know about pressure vessels, but definitely strands are super easy to make. There's just a lot of pretty easy ways to get that done.
If you want to know exactly how easy it is to make, I bought a induction furnace off of Amazon for something like $400 and heated it up to just over 1,000 degrees Celsius. And then what I did was I literally just pulled the basalt out and just dumped it on the floor. Floor caught fire, so I threw the entire pile into the snow that was just outside, and that's how I got the fiber. It's really that easy. One of the interesting things we noted about the basalt when it was melting, though, was that it actually produced oxygen. It thermalized. We found this out because I was trying to get a sample of sintered basalt out that had gotten stuck in the crucible out, and I hit it with a wooden stick, which, to my surprise, caught fire. Well, okay, sure, it would have caught fire anyway, but the way it caught fire was very, very dramatically. If you've ever seen those fantasy torches with like the 3-foot long flames, that's what it looked like.
Guys,
So-
I'm just laughing out loud here on my own, because if I hear these kinds of stories and you just hear, in this case, Elo say like, yeah, it's really easy, you just buy a furnace and yeah, you just do this, you just do that, and yeah, then you get basalt, and then you get this, and then you get that. I'm like, yeah, but it's so cool that you guys are crazy enough to actually do that, because so many people would say like, okay, let's write a paper, and that's it. And you and Elo and also Orion and others actually trying stuff out and showcasing that publicly to everyone, failures and successes. Yeah, that's what I feel is one of the cool aspects of this type of research, and I really applaud you for trying it out and sharing the information like it is normal, which is not. But I love it anyway.
It was my first time taking the plunge to actually buy all that equipment. Normally, my approach is much more calculated than. At that point, I was like, okay, so do I take the plunge? And I said, you know what? No one's done it. I've searched Google. I can't find research papers on this.
This is how science happens. This is how science should happen these days. Rather than the university lab doing it, you just buy the hardware off the internet and do it yourself, and then you do science. And to hell that it's not peer reviewed. You're doing scientific research. It's MythBusters style, but it works.
It is MythBusters style, but it works. Yes.
So before we
scientific poking it with a wooden stick, but
it has to be simple enough to do in your backyard if you're going to drop off, step out of a rocket and have it work.
So before we wrap up here, because we're going to have to wrap up pretty soon because it's getting quite good to the end of the time allotment here. Do we still have Julian with us?
Yeah, I'm still here.
Excellent. Oh, of course. So, can you tell us a little bit about your petrochemical alternatives before we wrap up?
Yeah, so the problem is, as I've already discussed before, that there's really, don't have oil on Mars, and if you want to produce basically anything that involves plastics, that involves petrochemicals, like for example also medication and other stuff, you need another way to get those hydrocarbons. And we thought about this, and there's basically two ways. You can pull them from the atmosphere, from CO2 and methane and stuff like that, or you can go another route and just use plants and let them do the work for you, because plants are quite easy to farm and it's not that expensive. And so we use that to get really complex hydrocarbons really quickly. And it's basically a process of burning those under the right conditions. It's pyrolysis. And from this, after getting a tar-like mixture, that is really kind of disgusting, honestly. You can crack it, and you can get different hydrocarbons that can be used as building blocks, and you can then work from there to actually have an entire industry built upon plant mass. And because it's actually burning the stuff, it's getting exothermal at a certain point of burning those.
So when you say crack it down for your smaller hydrocarbons, I'm assuming you mean through fractal distillation, right?
Yeah, basically just cracking like you would do with oil as well. If I'm not mistaken, I'm not that strong of a chemical engineer. My background is more in the biological part of this. But yeah.
Well, that's...
So basically, yeah, it's...
Sorry, go ahead, Julian. Go ahead.
The idea is basically just to get the plant hydrocarbons and get them into a form where there's more aromatics and other stuff that is actually very useful to chemical industry.
Okay, well, I think that's about... I think it would be a good time to wrap up there. We'll just go ahead and reel off the outroductions, as we like to call them. Nut, do you want to go ahead and say your piece?
Yeah, thanks for tuning in, everybody that was live with us today. Once again, sorry for the technical issues. If you're watching this back at all at a later date, you should find relevant links or the information discussed in today's show underneath this episode. Just look down in the description. If not, feel free to reach out to myself or any one of the guys here on Twitter.
I've been Rich L-B, co-host of Becoming Multiplanetary. I've been sitting in here with these guys on this special episode of Total Space, and it was honestly a great opportunity to talk with all you Nexus Aurora folks out there and all the various projects that you're working on. It's really, really interesting stuff. Definitely something I'd like to come back to and dig a little deeper sometime. So, and with that, we'll pass off to Adrian if you want to have any closing remarks before we wrap up.
Thank you. So it's not just hardware that we do here. We also engage in software production and in visualizations of space activities. So actually it's a full rainbow of activities. I'd say give it a try, pass by our Discord server. We have plans to actually go a bit higher up in this organization domain, so hopefully by midsummer we will have a far better platform to host all these projects. But until then we do what we have, and I think this is the spirit of Nexus Aurora. Use whatever you have on hand and make it work, and I think this is where we might be a source of inspiration for others. Thank you for inviting us.
You're very welcome. And Cohen, any remarks?
No, thanks again. I think Adrian encapsulated Nexus Aurora very well, and I think this talk and the stuff that you hear from all of us during this conversation, I think embodies what Nexus Aurora is all about. So people get a good insight into a very small part of all of these projects that we do. So feel free to dive deeper and join our Discord server. And again, guys, thanks for inviting us, and we'll talk soon.
Awesome. Sam, closing remarks?
Yeah, thanks for having us. It's great to be able to nerd out on camera. And if you've seen this and think that sounds cool, I wonder how XYZ works, or I wonder if my experience in tangential fields could help, do join. We take anyone and we'll answer silly questions and have silly discussions.
Thank you very much. Elo, any closing remarks?
Yes, I do have one. A lot of things that we produce are, how do I say it definitely does not fit the usual image of science. It's very much a bunch of people trying things out that may or may not work. And I definitely think that we won't get there. We probably won't get into making humans multiplanetary quite as efficiently as, say, an entity like NASA, but we will get there for certain.
Awesome. And Orion, you have any closing remarks?
This was an awesome project, and I had a ton of fun working with all these guys.
Awesome. And Julian?
Yeah, so I can just really agree with everything that has been said so far, and I really do urge everyone that is interested in this sort of thing to join us, because we're always looking for more people to help us with our stuff. And if you're interested in the research of the EHRI, we will soon be releasing our first journal, where we will compile all of our articles about the research that we have done in the last year. And yeah, so do look forward to that.
Thank you very much, you all, for your closing remarks. And this is the part of the episode where I reel off our Patreons. So each episode we make a point of noting our Patreons and thanking them for their support. So we actually have one new Patreon since the last episode was published, so we're going to mention them as well. Our new Patreon is Howard Walker. Welcome, Howard, to Total Space Network. And we have our other Patreons: Sammy Escuro, What About It, Jishwan and Sebastian, Gio Padiari, Framric, Susie R, and Marco. Thank you all very much for supporting the channel. Your support means a lot to us. And if you like what you see here, and if you feel like you want to be a part of the Total Space Network, you can catch us over on Patreon if you would like to become a Patreon at patreon.com/Total Space. Guys, thank you for coming along this week. It's been a great episode. It's been great having you here. It's been great to discuss all these projects with you. It's been good fun listening in and hearing about all these different projects. And there's a lot of good stuff going on there. You've all got a good thing going at Nexus Aurora. Definitely keep at it, for sure. And to all our listeners, hope you're having a great 2021 so far. And it's a new year. We've put 2020 behind us now. That was a complete dumpster fire. Let's look forward to 2021 and let's make it a great year.
And thank you once again, Nexus Aurora, for joining us tonight. It was a really good chat.